Hi, everybody. Welcome to another Sharkness General Interest webinar. My name is Armin Sobani, and I'm a Sharknet HPC technical consultant based at Ontario Tech University. And here is my email for any further consultations after this talk is over. Today's talk is about remote development on HPC clusters with VSCode. So let's first have a quick intro to VSCode. Visual Studio Code, or VS Code for short, or just code as the name of the executive file, is a GUI source code editor and debugger for Windows, Linux, and Mac OS. It's been being developed by Microsoft since 2015 and is completely free. For once, Microsoft did the right thing and made it open source. And it seems it's becoming a trend with other Microsoft products like Windows Terminal that we are going to use today as well, which is a good sign. Its repository is in GitHub, also owned by Microsoft. The source code is released under MIT license, but binaries can be built and distributed only by Microsoft. It's written in TypeScript, JavaScript, HTML, and CSS, and is based on Electron. To have some ideas about VS Code popularity, it's enough to say in the 2021 developer survey of Stack Overflow, VS Code ranked #1 with a significant lead among the top IDEs, and this was the case for the past 4 years in a row. This is a highlight of VS Code most important features. Intellisense is the Microsoft terminology for code completion. Git support is built-in feature in VS Code, but it needs an installed version of Git to operate. Interactive debugger is what makes VS Code act as a true IDE or integrated development environment. And last but not least, almost all aspects of VS Code can be extended with extensions. The whole remote development facility that we are going to cover today is built on 3 extensions: remote SSH, remote WSL, and remote containers, for example, for Docker. In today's talk, our main focus will be on remote SSH and just a little bit of remote WSL, but not remote containers. Depending on what you want to achieve, remote development on HPC clusters can be done on login nodes or compute nodes. On compute nodes, there are 2 approaches: SSH proxy jump, also known as jump hosts, SSH tunneling, also known as port forwarding, each having their own advantages and limitations. For example, while working on logging nodes that has minimal setup and is kind of convenient, it's not good candidate for debugging. And you can't do any debugging on, for example, GPU. We are going to explore all these 3 methods today and see their pros and cons in action. But before switching to the live session, maybe it's worth mentioning there is another open source project by Microsoft on GitHub that has a close relationship with VS Code. VS Package is a free cross-platform C and C++ package manager for managing libraries and dependencies. It was first developed for Windows, but later became available for Linux and Mac OS, as well as different architectures like ARM processors and even the IBM Power GPUs. It contains more than 1,500 open source libraries. The good thing about it is that you can easily install it in your project space on our clusters, and it supports VS Code. But we don't cover it in today's talk. But if you want more information, you can check this URL. Because we have lots to cover today, so let's change our gear and switch to the live session. All the materials we need for today's talk is on Sharkness GitHub account. You can use this URL to check that. Okay, here is the repository on the GitHub. If you search for the Sharknet and then repositories under there, the VS Code is the one of the three. Sorry, VS Code HPC. And here is the URL, but maybe it's too small to see here. So the thing that I put together here is our usual suspect in HPC computing. It's Monte Carlo estimation of pi number. I try to put codes in the different languages. The ones that I chose was C++, CUDA, Jupyter, and Python. And you can also see the languages used here as well, and the person. The thing is that if you go, for example, to Jupyter, the Jupyter notebook here has a summary of the method. There is a link here that you can check that says the theory behind the whole thing. And you can see the Python code here and the output as well. But here, let's see, in order to do that and open this whole project on VS Code, what we should have as a setup. So basically, you need the Visual Studio Code installed on your computer. So for example, if you use a laptop for your development, you should have VS Code installed on that. But we need some the extensions in VS Code to be there to do all these things. The most important one is this one, the first one. The one good thing about the extensions in VS Code is that you can also have compile an extension pack that put together lots of extensions together. This one is assembled by Microsoft and has all the components that we need almost, C and C++. And the one that we actually want for this talk is Remote Development Extension Pack, which is also another pack. If you check that, it has all the remote SSH containers and WS. But in addition to that, for Python part, we need the Python extension. You can click on this to see them, and even you can install from those, but it's better to go to the extension section of the Visual Studio Code and install all these extensions there. Python actually includes Jupyter in it, and also Pylance as an optional dependency. So if you install the Python extension by Microsoft, these two will be there. But there is another one that I also recommend, but it's an optional one, Visual Studio Intellicodes, that can use AI to, have suggestion in Python and also Java. For the GPU part and debugging on the compute node, we need Nsight Visual Studio Code Edition from Nvidia. And there is another optional one. We use CMake tools that is included in the C and C++ extension pack. But if CMake is not your cup of tea and you work with Makefiles, Microsoft recently released the Makefile tool support, but it's kind of in beta or preview phase. So maybe it's not as feature rich as the CMake one, but I also included a Makefile, here at a minimal one. So if you want to explore with this tool, you can do that. For GitHub pull requests and issues and easily log into the GitHub, we need this one, but we not rely on it. So these three all are optional. And GitLens is really good addition to default Git support on Visual Studio. This is on your computer, but depending on what platform that you want to do the remote debugging, you can do these things. For example, on Compute Canada clusters, you have to load these modules that we need, CMake, CUDA, SciPy stack, and also IPy kernel for the Jupyter one, the Jupyter notebooks. But the thing is that the only way that you can easily do that to be supported under Visual Studio Code is to put them in your .bash RC. So you should put this module load command in your .bash RC and then try connecting using Visual Studio Code to it. And on the other platforms, for example, Linux, Windows, and macOS, if you want, for example, do the same thing, because the whole the setup that I put there is completely cross-platform. So you can easily put it on your computer, on Windows, and do all the things on Windows operating system, on Linux or macOS, depending on the platform that you have. But depending on what you are working on, you should install these things as well. One thing that I should mention here is that for the CUDA toolkit under the Windows, you can compile the codes both under the Windows operating system. If you want to do that, you need a compiler. So Visual Studio Community Edition, which is free, is a good thing to support C++ and Python. And for the MPI part sample, you need a Microsoft MPI install and also CUDA toolkit. But if you have, like me, have WSL2 or Windows subsystem for Linux on your Windows computer and want to develop there as well, there is a way, because Nvidia recently released Nvidia drivers for WSL with CUDA and DirectML support. So, but you should first install a special drivers under Windows that supports CUDA both under Windows and WSL. And after that, you should follow these instructions under this link to install the CUDA toolkit under the WSL. Once you've done that, you're all set. So let's start with cloning this code. I first start with the Windows and WSL, then switch to the remote cluster. So first you copy this URL, and then I right click on the VS Code here because I want to start from a new window. I just select a new window here. So when you do that, you get something like this. And now you can click on clone Git repository, or you can also use the command palette if you don't have it here. So it's not bad to show you that. You may already know that, but under VS Code, command palette is Ctrl-Shift-P, or also F1 on the keyboard. This command palette is like a paint palette, so you can mix and match commands. But because of that, the most recently commands also only showed here. So the things that you see here may be completely different from mine, because depending on what I used, they are not here. But as soon as you start typing, for example, if you want to do git clone, you just put this and then go to git clone. But we use this shortcut here, and then put the our repository here, and then press enter. Then it asks where I want to put the whole thing under the Windows operating system. So I put it under the source and click here. So next thing I say, open it under the same window. After doing this, it tries, because it's based on the CMake, it tries to configure the whole thing. It's first detected the Microsoft Visual C compiler, and then the type of the compiler. This whole sample code in C++ is based on C++ 14 data standard. So it checks whether the compiler supported, and then for the OpenMP version, it detects if it is present, which is, and then for the MPI, it already found the Microsoft version of MPI, and also found the CUDA and the Nvidia driver. After doing this, Because I have the CMake tools, you can see that it's already configured. To switch between the debug or release version, I can click on this. If I want to debug, I switch to debug. But let's first here, because we just want to show it, switch to release version. And here you can select your compiler. But for this, you should, if you want to compile the the CUDA code, it should be AMD 64x86, which is there by default. And after that, if I want to build all the samples, which are these ones, I should select all build and then click on build. In a start to building the whole code, and depending on what I want to run or debug, I can switch. The default here is MCPI CUDA. So if I click this, I can run the whole CUDA version of Monte Carlo pi estimation. But by running that, I end up in an error. It complains about the PTX. By default, you shouldn't see that. I'll explain it later. But the reason for this is that I've installed the CUDA compiler, CUDA toolkit for both WSL and Windows. And when CMake wants to do the thing, it's defaulted for the WSL. So it doesn't select the right architecture for the Windows version. The only thing that you need to do, and we are returning back to this on the cluster as well, but here I need to first go to the CMake tool extension here and click here and edit CMake cache. And it's default to the 52, but because my laptop has you can see here Nvidia RTX 3050, I should change the architecture to 86. I'll show the table for that later, but for now I just save this and it tries to reconfigure, and then if I run, usually it both build and run it again. So you can see it's quite fast. It's 92 milliseconds using 10 million tosses. If I want to do same thing on my WSL, I only have to start my WSL or Windows subsystem for Linux here. I explain about the Windows terminal a little bit later, but let's first go to Ubuntu. This is my WSL. And now I go, if I want to do editing here, I go to the, let's go to the source here. This is because the default, I switch to the WSL Linux, file system. Here I already have VSCode, but let not cloning again. But in order to do editing WSL, under WSL, you can go to that folder and just put code and dot here to initiate the WSL remote connection to the WSL. This is another VSCode window here. And you can see by checking this. Now I am on WSL Ubuntu. This is possible using the remote WSL extension. If I switch to my other Visual Studio, which was under Windows, you can see that this is like this. So on the default or local platform, you shouldn't see anything here. It's just your computer. But on remote ones, you should see the one here. Because I'm not sure what was the version that I had, the first thing I should do is to git pull the latest version. So let me do it by going here. You can also do it from here in the extension, but this shortcut is better. Oh, and I see this one is actually, no problem. This one is actually from another repository that I have, but no problem. I can do it. Let me do it again. It's not really hard to do that, but I need to close this one. Oh, I did it wrong, but no problem. Let me just remove the whole thing. And I can do the Git cloning also here rather than inside the VS Code because I already have the URL. I do it and then change to this and code dot. So this one is the latest version. So here is the same thing, but under the WSL, so that the compiler is GCC 9.3 on my Ubuntu 20.04 on the WSL, and I have installed the CUDA toolkit and all the things here, and also MPI. So I can run it here again, but first let's build all. Here you should do the same thing. You should switch to release first, for example, and the compiler, the default compiler is a GCC 93 here, and I can click to build all the programs. OpenMP version, sequential, and MPI, and then CUDA. And if I want to run the CUDA version, I just, for example, click this. Oh, this one is sequential. So it takes more than that. But let me stop it for here because it's under the WSL, it takes even more. And switch to CUDA and then run it. So here is also quite fast, about 255 milliseconds. But before switching to how to connect to remote, clusters here, let me show you one more thing here, because it's better to do it here. The whole project configured using the CMake. This CMake is not your grandmother's CMake, I mean the old one. The modern CMake is quite powerful, and with the few line of codes, you can, build very sophisticated, setup and for your, project. So let's explore it here and then switch to the remote, clusters. And the only thing that you need to have here is a minimal CMake list. We first check for the version, which is 3.18. The minimal that we need here, because we rely on modern CMake that has lots of features, especially for CUDA and other things. The minimal is 38. Starting from CMake 3.12, you can also specify the maximum version. The good thing is that if the CMake version is even higher than that, by putting 3.20, it's use only all the features of 3.20. So it's not gonna broke, under the higher versions of the CMake. This is the project, and the type of the file that we have, or the project, is basically C++. You can also add Fortran, and also we have CUDA. You can add CUDA with a space here, but we didn't do that. Why? Because we try to first check if the CUDA support is in the system. If it is there, then we enable the language, and then try to add the CUDA subdirectory. But if it is not, the other things, go on as well. The same thing about the C++. So we have two type of languages that needs compilation here. One is CUDA and one is C++. For the C++, we add subdirectory in under the C++, and for the CUDA thing, if we detect it, we go to the CUDA here. So for the CMake list in the C++ folder, we do exactly the same. For the sequential version, this is the code to include it. And for the OpenMP, we try to detect whether OpenMP is supported or not. If we found the support, we just add the C++ code for that part. And again, for MPI, the same. But if it is not there, we only compile or build the configuration for the sequential version. And this is the CMake list for the CUDA. You can see it's really minimal. With minimal codes, you can put all the support for your platform. The good thing is that when you put the CMake, I always say this, VSCode and CMake go together like a peanut butter and jam. So when you have these two together, it makes a really powerful setup that you can do anything. The good thing is that there is no other setting required because VS Code can get all the information for Intellisense and also Linter from that. So let me show you. By doing this, if I open my sequential version of the file here, all the things is there. It's already detected all the, thing necessary for the code compilation. So if I put include here, as soon as put here, I can see all the include files that are needed. For example, for the OpenMP version, I can easily search and find the, for example, OMP. So as soon as I put here and type, let me do it like this, type OMP, it will be there because it was detected and the header file is already there. So the code completion is there. And also about 3 months ago, Microsoft included the linter for C++ in the C++ extension. So as soon as you type, it shows all the errors. So for example, if I go here and put C out and like this and something, and then check here, it says that expect a semicolon at the end of the command. So this is the linter. As you code, it tries to find all the errors and you shouldn't compile. You can see all the errors right there, which is really cool. And once you do this, if I save this version here, which wasn't completely different, but this one, for example, which has an error, it's not finished. And if I go here, it says that expected the file name. But let me save this one. As soon as save, you can see under the Git that you have a new change. If this change is something that you intended, you can add it and then commit. But if not, you can revert to the last version, discard changes. So this is how it works in general. But the good thing about having CMake like this is that all the things are there without any setup. So with the same thing, you can also do the debugging. Here, I can put F9 here and then start debugging by clicking this one. Oh, but before doing that, I should switch to the debug version here. If I don't do that, it doesn't work. But I tried to show it during the debug session, a remote session on our cluster. So let me stop the whole thing here. and go for the setup for our remote setup. So the first thing that we need to configure for the remote setup is, let me first open my Visual Studio Code here, is configuring the SSH config file. But it's better to do that under the VSCode because it's an editor and also has support for it. So if I go to command palette and search for remote SSH, there is an option which is Open SSH configuration file. If you click on that, under the Windows, all the config files is under the .ssh. So this one is the one that we use. To have a basic one, it's better to add a line like this, host a star, and put the default username. So in all other ones, if you don't specify the username, it would be a sub one. But if it is different, you can specify it with user as well. So it's a good starting point in your config, and then you can put the servers or clusters that you work with. So I put Narwhal here, and this is the name for that, and this is the complete, the FQDN for the Narwhal. And this is an option for forwarding agent, which is a good one, and we will see later what it means. So this is our config file. The good thing is that now for connecting to Narwhal, we can only type Narwhal on our command prompt. Now let's do the configuration for the SSH key. For doing, remote debugging or remote development, SSH key is really important setup. So let's put some time for figuring how it works here. I'm under the Windows. Under the Windows, in the past, it was kind of tricky because there weren't any OpenSSH thing, and you should use a software like, for example, MobiXterm and those things. But it is a thing of a past. Under Windows 10 and also 11, that I'm using actually 11 here, OpenSSH is part of the system. It comes with the operating system. So you shouldn't, choose, for example, something like MobiXterm. An important thing is that VS Code under the Windows, under the hood, uses this OpenSSH. It has all the commands that you can find it under the Linux and also macOS, because they are also the unit, those based on Unix operating system. So if I put which SSH, you can find the path to Windows OpenSSH, which is here. And you can, for example, put this like -H here to see the help for that. And if we, for example, do this, we can see what programs are available. Okay. It shouldn't be like this, but maybe because I'm under the, Git bash. But the thing is that here, another thing that you need is a terminal, because the Windows, the terminal by default or console is only, it was only command prompt and also PowerShell. But Windows, Microsoft released recently Windows Terminal, which is going to be the default console for Windows 11 in 2022, this year. But for now, if you want Windows Terminal, you should download it from, you install it from the Windows Store. If I show you the, our page, you can find the link for the Windows Terminal here. There are 3 versions of Windows Terminal. I put only 2 here, the ordinary one and the preview version. Preview version has more features, and I really recommend you to install the preview version. And I have the preview version. You can see in my tab, which has this cyan, pre under the icon. By doing that, the good thing about the Windows terminal is that it's it's quite fast. It's based on GPU, and you can add all other things that you have. So for example, under the Windows, I have both Git Bash that gives you Unix commands under the Windows file system, which is my favorite, and my WSL, and also Windows PowerShell and command prompt. So you can easily switch between them. So for example, if I put, and I by default I chose Git Bash. So by default, if I open a new window, it's a Git Bash one. But for setting your remote SSH thing, I recommend you to use PowerShell, because some of the things that we want to do may be not working here, under the Git Bash. But you shouldn't do it under the WSL, because the WSL uses another, folder, and Visual Studio Code under the Windows relies on the OpenSSH, this OpenSSH, which the folder for that is here in the dir. If I put here SSH, these are the files that we need for the configuration. So in order to generate your SSH key, you just put SSH keygen, and then the type of the one that we recommend now is ED 25519. And I recommend you always put a comment in that includes your email address here. And that's all. So the default file name is this. You can enter this for the default name, but I really suggest you to put a passphrase. Sometimes in the documentation they say that you can put enter 3 times, but I really recommend you to use a passphrase. So I put a passphrase here for the security reasons, and I type it again. Okay, after doing this, if I check, go to SSH here and check and the good thing about the PowerShell is also accept LS in addition to dir. So next thing that we should do is putting this public key as in our CCDB. So the only thing that you need to do is copy this, go to CCDB, and under my account, manage SSH keys. You can add any number of SSH public keys here. But I removed the previous ones, for example, paste it here. By default, it puts the email here. The good thing about putting your email here is that you can always be sure that it's a public key. If it is a private key, then you don't have this email at the end. And then I add the key. Once I do that, I can SSH to Graham. I just put the Graham because we put the Graham there. If I do that, something went wrong. Oh, maybe. Let me try here. Okay. Now it works because it takes a little bit for the CCDB to put this. Now it works, but it asks for my passphrase. So if I want to go to the Graham, I should put my passphrase here. But on Graham, for the staff, we have also multi-factor authentication, but you don't. So I should put it here and get access to Graham. But this passphrase thing is kind of problematic because each time then I should put my passphrase. Here comes the SSH agents now. You should add your SSH key now using SSH add command to your default key. So you can put it in both PowerShell or if you have a Git bash there. So I put SSH add. But before doing that, under the other operating system, the whole procedure is the same. But under Windows operating system, if you haven't used the agents before, the next step is to first run the agent as a service. So you go to the start and type services here and go to the services application. Here you go down in the list to open SSH. Here, open SSH authentication agent. I've already done that on my computer, but you should do it once. You click here, and if it is by default manual, you should put it on automatic and start and apply. Then it will be there, always will be there. So after having our SSH agent running, you should add your SSH key. If you put SSH at -L, it shows that there is no key yet. So I do SSH add, and then the path to my SSH private key. So here I put ed. Sometimes this is my private key here. Oh, because I didn't put ID here. Oh. Okay, and I should put my passphrase. Okay, all set. From now on, I can log into all Compute Canada clusters with my SSH key with the passphrase, but without typing anything. So let's try on Narwhal. It works. And the same thing happens for Cedar and Graham. But on Cedar and Graham, I, as an staff, should use my OTP, but you don't. But because Narwhal doesn't have the multi-factor yet, because it's in the initial phase. During today, I use Narwhal for all the cases because I can bypass this OTP thing that you don't see. So under the Narwhal, I can now log in like this. Once I have this, then I can easily go and do the whole thing on Narwhal like it's on my computer. How I can do it is, I right click on VSCode here, go to new window again, and then press F8 or command palette and select Remote SSH Connect to Host. When I do that, it lists all the hosts defined in the config file that we saw. And I click on Narwhal. So here you can see all the details. If there is something wrong, then it shows. And after doing that, now I'm on Narwhal. I can open a file or folder. I choose open folder. This is my home directory on Narwhal. So I go to, for example, development there, and I can put here. But because I don't have the whole project there yet, it's better to, rather than doing that, I go to clone Git repository, and then let me copy the, where is that here? Let me close this one and copy this one again and paste it here like the way we did on. And now I say to put it, development is under my project. So I put it here in the project space on normal. After finishing that, I can open the whole project. It takes some time. Now it's open, the whole project is on my project space on normal, and I am remote debugging on normal. You can see it here. It's exactly the same as I was on my Windows laptop. It starts to configure thing. Sometimes you get this error. I get it in normal. I don't know why, but you can ignore it. But it tries to configure things. Sometimes it takes more. I don't know why, but everything works. Let me see. Today, Narwhal has some problems, maybe because of that. And this is the thing you see in the live sessions sometimes. The thing that you, let me see my terminal. My terminal is working, but it couldn't. When you have CMake tools extension, it tries to automatically configure the whole project. If it doesn't happen, you can try to do it yourself. So I go to command palette, add say delete CMake cache and reconfigure. If I do that, it will start. Okay, so it tries to do the same thing. It tries to detect the compiler. Under Compute Canada cluster, there are different ones, but the default one is 9.3, which is for the standard environment 2020. So it could find all the things here. And now when it's finished, I can build all. And for example, run the CUDA. I can run the CUDA code because it requires that you can run it on the login nodes. And I'm on the login node now. But I can easily run the, because it's a small thing, no problem to run it under the login node. So if I go and run this one, I can run the parallel version of the task. While it's working, let me show you something here. For whole things to work now, you should add all the modules that you rely in your .bash RC. So if I cat my .bash RC here, you can see I added the module load command here, the one that was in the the repository here. So I have also, for example, the default CMake under the Compute Canada is maybe lower than 3.18, but by loading the CMake, it goes to the latest version, which is, for example, 3.21. So now it's finished, and it takes a long time. I don't know why, but maybe because it's a debug build. Another thing that I want to show you here is that the Jupyter notebook works out of the box here. So one of the other ways to develop and run Jupyter notebooks, because it if you have the Jupyter extension, which is part of the Python extension now, the only thing that you need to do is to select this, and this IPy-kernel thing is necessary for this Python, Jupyter notebook extension to work. When you run it for the first time on any cluster, it takes more time. So because I did it before, it's really fast. So if I restart, for example, here, and then selecting the one that by default loaded, it's really important to check the right one, which is the, let me see, if I do module list, I can see the Python version because it can find other Python version. So it is 3.810. So it's you should select the one that is loaded actually, and then run all. So you can see all these things are running, and you can see this plot generated again. Let me generate it again to have the, or no, I should run all of them. Okay, now you can see the plot, and you can easily edit your the Jupyter notebook by adding new code line, for example, or markdown. So if you want to add a new, markdown here, you can just put it and type, or a code one here, you can add it here and then save the whole thing. One thing that I found under the cluster, which is important for the version control, is that when you save your changes, for example, this file is changed. If you save these, and if the files are on project space, which is usually Lustre file system, the Git extension on VSCode can't, detect the changes. So it doesn't show anything changed. So you need to go to here and click on the refresh button. So it shows now that one file is changed. But if you, for example, do it on your home directory on Narwhal and Graham, I tested it, it works fine. So maybe there is something with the Lustre file system. So I can change it back to this. But the next thing that I'm going to show you is yes, there is a question. This Jupyter notebook running on clusters login node. Yes, it is like that, but you can run it quite on the compute node as well. So let's see how we can now switch to compute node. For doing that, there is one thing that you should consider. Let me go exit here. The whole SSH key in CCDB is really cool thing, but the problem with that is it doesn't support on compute node. Compute node don't check the SSH key in the CCDB. That's why it's not gonna work. So you should the caveat is that if you want to go directly to compute nodes for the for example the running the VS Code there, you should put also your key on clusters, each cluster by SSH copy ID command. So I mean the old way, and it should be done for each cluster that you want to work on it. So SSH copy ID is available on for example WSL and on Linux and macOS, but under the Windows and for example Git Bash and PowerShell is not provided by the OpenSSH. But it's no problem. You can easily do that. I have the command here. Let me I don't have it here maybe, but no problem, I can put it. To put your SSH command there, you can cat, but you should be sure that it's your public key. So you can put it with this command to the each cluster. So for example, if I want to put it on Narwhal, I should put this command cat and then SSH to narwhal, and then cat this to .ssh authorized keys. If you don't do that, when you switch to the login node, the compute nodes, it asks for your password again. So it shows that it now works. If I now, under the good thing about terminal is that you can have other pans. So if I put Alt Shift D here, I can open another window here. Now I can SSH to narwhal and can see the file is already in SSH. Yes. So on narwhal now, here, I salloc a session, for example, 15 minutes, and my account, which I use CC debug to be, you should put yourself here. So I'm now allocated a compute node. The name is NC. And here I do SSH to, okay. Now that the, compute node is allocated, using a method which is called proxy jumping, I can connect directly to that compute node from my computer. So I need to use -A for agent forwarding and -J for proxy jump. And the name of the login node that I want to proxy jump using that, and then the name of the compute node. So using this way, I can connect directly to the compute node that I allocated. For if this is the first time it asks for the fingerprint, that I say yes, but without typing any password, I gain access to the compute node. Now I can do the same thing with a VS Code. How can I do that? In VS Code, I've added a line under the name VS Code Narwhal, and it has all these things. This one is for the forward agent -A, and this one is for proxy jump. But the only thing that I need to change is the compute node name, which can be different each time, but maybe sometimes it's the same. When I save this now, I can go to remote SSH. Oh, sorry. Connect to host and select VS Code Narwhal now. So if you check here, I am on VS Code Narwhal, and it's the compute node. Why? Because if I open the terminal, you can see that it's NC 3105. Now, if I open the folder, I'm actually on the compute node.